whose direction cosines are connected by the relation an plus bm plus cn equal to 0 and ul square plus vm square plus wn square equal to 0 are parallel, then the options are A, ua square plus vb square plus wc square is equal to 0. Option B is u square A plus v square b plus w square c is equal to 0. Option C is a square upon u plus b square upon v plus c square upon w is equal to 0. And option D is u square upon a plus v square upon b plus w square upon c is equal to 0. Now eliminating n from the two equations, we get n equal to minus times al plus bm upon c from the first equation. Substituting this value of n in the second, we get ul square plus vm square plus w times al plus fm bm minus divided by minus c whole square is equal to 0, which simplifies to c square u into l square, c square v times m square plus w times a square l square plus b square m square plus 2ablm equal to 0, which reduces to c square u plus wa square times l square plus 2wab times ln plus c square v into m square is equal to 0. Dividing by m square, we get c square u plus wa square times l upon m whole square plus 2wab into l upon m plus c square into v equal to 0. This is a quadratic which gives us the values of l by m. If the lines are parallel, then the roots of the above quadratic equation in L by M are equal, so that its discriminant should be equal to 0. Equating the discriminant equal to 0, we get 4 times a square b square w square minus 4 times c square u times a square plus a square w into b square w plus c square v equal to 0, which gives us a square c square into vw plus b square c square into uw plus c4 into u v equal to 0. Dividing by c square into uvw, we get a square upon u plus b square upon v plus c square upon w is equal to 0, which shows option C is correct. If the direction cosines of two perpendicular lines OA and OB are L1, M1, N1 and L2, M2, N2, then the direction cosines of the line perpendicular to both OA and OB is L1 plus L2, M1 plus M2, N1 plus N2, or L1 plus L2 divided by 2 plus sigma L1 L2, square root of this, M1 M2 divided by 2 plus 2 times square root of L1 sigma L1 L2, and N1 plus N2 divided by square root of 2 plus 2 times sigma L1 L2. Third option is M1 N2 minus M2 N1, N1 L2 minus N2 L1, and L1 M2 minus L2 M1. Last option is none of these. Since OA and OB are perpendicular, we have the dot product is 0. That means L1 L2 plus M1 M2 plus N1 N2 is equal to 1. Also, the modulus of their cross product is equal to 1, because sin 90 is equal to 1. That means M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square plus plus L1M2 minus L2M1 whole square is equal to 1, because it's equal to sine 90 whole square. Now let LMN be the direction cosines of the line perpendicular to both OA and OB. Let it be OC. Then OA dot OC is equal to 0 and OB dot OC is also equal to 0. That means LL1 plus MM1 plus NN1 is equal to 0, and also LL2 plus MM2 plus NN2 is equal to 0. Now from the two we can get the values of LMN proportional to pi using cross multiplication method. We get L upon M1N2 minus M2N1 equal to M upon N1L2 minus N2L1 and N upon L1M2 minus L2M1. Therefore, these are the direction ratios of OC. That is M1N2 minus M2N1, M1L2 minus M2L1, L1M2 minus L2M1. But from second, we know that M1N2 minus M2N1 whole square plus N1L2 minus N2L1 whole square plus L1M2 minus L2M1 whole square is equal to 1. Therefore, they are the direction cosines of OC, because sum of their squares is equal to 1. Hence, option C is correct.